Hello there, I'm Jimmy Vegas and welcome to the 17th video in the beginner's guide to Unity 6. This time we'll be looking at something called Raycast. Remember to subscribe and click the notification bell to stay up to date with every tutorial I upload. Feel free to leave a comment and drop a like. I also have a Patreon page where you could help be a part of this channel, and you'll also find all the scripts and the assets to this series there too, along with plenty of other things. You can also now join as a free member. Now on with the tutorial. So let me briefly explain what Raycast is, what it can be used for and why it's useful. Raycasting will cast out an imaginary beam in front of whatever it is attached to. So it could be, for example, your player. It will then tell you just how far away whatever object you're looking at is. So as an example, our player is looking when it starts at this wall or this fence. The Raycast will return a numerical value of how far away you are. Why is this useful? Well, let's say if you want to walk along somewhere, you want to open a door, but you don't actually know, or the game doesn't know, just how far away that door is. And you want to be able to detect how far away it is before you would display something on your screen to say, for example, open door. And that is all done via Raycasting. It's not a complicated thing, but once you've got a Raycast set up in your game, you can reuse it multiple times and actually have it feed back information regularly to pretty much any script. How do we get this set up? Well, there is one simple thing that we need to do, and that is a script. Yes, it's all done via C# programming. So let's go to our scripts down here. Let's right click, create a new script, and we'll call this, just call it Raycasting, if I can spell correctly. And let's open that up in Visual Studio. Once we're in here, we can get rid of the start method because it isn't required, and we don't need any of the annotations, so we can delete those. We do, however, need to declare a couple of variables. The first variable is going to be a float, and as I mentioned previously, that is a decimal value. Because we can determine how far away something is to a decimal value, it does have to be a float. Now, up to this point, we have used mostly a serialized field to declare a variable. This time we're doing something a little bit different. We are going to have this as a public variable, and we're also going to have it as static. Now, the reason that we make something public and static is so as that other scripts within your game can access information and exchange something like a variable between it. In this case, what we want to do is we want to be able to have the Raycast create a number, but also have other scripts reference that particular number. So as another script, say a door for example, can tell how far away you are from it. So now we have public, static, and we'll have it as a float. And we can call it anything relevant. So we'll say distance from target with a semicolon. The idea here being how far are we from our target, or what are we looking at? Now, because this is a static variable, we're not going to be able to see this value in our inspector panel. And for testing purposes at this point, we do want to be able to see it. So what we do need to say down here is serialized field in square brackets. Have this also as a float. And I'm just going to call this something like to target semicolon. So this to target variable is simply going to be the internal version of this public static float distance from target, i.e. we'll be able to see this value in our inspector panel, so we just have to make this value always equal to this value. So how do we create this Raycast? Well, firstly, let's go into void update. So in the update method, we need to say another variable here, and this one doesn't need to be serialized, it doesn't need to be public. Much in the same way as we did with the starter script, we had this variable here, the integer, my other number. We can do the same thing. Now, we've declared variables outside of methods. However, you can still declare variables inside methods. So we'll do that here as a good example. We'll say Raycast raycast hit, and then we can call it anything we want. Because it's a hit, we'll just call it hit, something really, really simple. So that means that we're saying, well, what is the value of this? So we can say if physics, and you can see it's already trying to predict what we're writing here. So physics.raycast, and in brackets we need to say transform.position, because this is basically the way of shooting out this imaginary beam that we have, comma, and then we need to basically tell it which direction. So the direction we want this to go in is going to be forwards. So we can say transform direction, and after that we can say in brackets basically which way. Like I said, we want it to be forward, so we can say vector 3 dot forward, close bracket, comma is next, and then you can see it's already predicting what we're writing. Out means output, i.e. where are we going to output this information? It's going to be hit. So after that we can close bracket, open curly bracket, hit return. So what is happening here is every frame that this raycast is running, it's obtaining information from the forward direction and it's putting out a number into hit. We can then take that information and put it into both of these variables. So we can say toTarget is equal to hit dot distance, semicolon. So now we can see what that value is going to be inside the inspector panel, and we also need to make it in the public static version as well. So we can say distance from target equals hit dot distance, semicolon, and save. So this script, although is very short, may appear a bit daunting because of how it's presented in terms of what is actually happening in the if statement. Because up till now, the if statements we've done have always been if such and such is equal to true and something equals true, then do this. This, on the other hand, is doing something differently. It's saying if the raycast is being shot out, return the value in hit, and then make these two variables the same value as whatever hit is. So now let's head back into Unity, give it a moment just to compile. And when it's done that, we need to attach the raycasting script onto, well, it can be attached onto anything, but most of the time it's going to be onto the player. For example, if we were to attach it onto the wall, it would still cast out a raycast, but it wouldn't do anything. It needs to be on whatever object moves the most, i.e. it would be the player capsule. So let's drag and drop raycasting onto player capsule. And if we scroll down, we can see that the only variable we have now is toTarget. Remember I said that public, static, float, distance from target won't appear? Well, there we go. It doesn't appear. It does obviously still exist in the script, but it doesn't appear here. Now let's test out this player capsule with the raycasting on, and let's actually make sure that we can see a value. So if we have player capsule selected, make sure that we scroll down here, and we can see already that as I move around, you can see how far away we are from something. So let's look at this wall. And if you look in the bottom right of my screen where it says 7.549325, if we move closer to the wall, it will decrease. So it will tell you just how close we are to an object. Right up to it, you can see that we are just right next to it. So 0.5 appears to be the lowest it can get to, but that's fine. That's about right, because we're literally right up against the wall, but we're not right against the wall because the player obviously has some limitations in terms of the physics, so that's fine. So we can now determine that 0.5 is about roughly where we are to get close enough to an item. And if we look at the ground, it's not going to really work in the same way, simply because the player capsule itself is the raycast, so it's always casting outward. It's not casting anything else. So if we go this way and look at the wall, there we go. You could theoretically change what the raycast goes on to. So for example, if you put it on the camera route, it would work a different way as well. So let's try putting it on the camera route. You can have multiple raycasts in your game if you want to. It's entirely up to you. It's not important, it's not vital, it's not going to be too draining on resources or anything, but it will give you a good indication of how you can use Raycast and where you would want to use it. So on camera route, you can see that if we look at the ground, we're currently 1.46 away from the ground. As we look up further, go to the wall, we're still roughly about the same distance away. So if you want to be able to tell the difference between the ground and where you are now, then yes, have this on a player camera route. If it doesn't matter too much, then I guess it doesn't matter at all. Let's push this ball over here. You could have it just on the player capsule. I think I'm going to keep it on the camera route. That's where I'm going to keep it. Cool. So raycasting, as I mentioned, is vital in pretty much any game. Let me remove it from the player capsule. There we go. So basically to detect how far you are away from things, you know, whether it is an enemy, whether it is a door, whether it is a collectible or whatever, it is important to that extent. So next time what we'll do is we will interact with objects, and that's where we'll incorporate the raycasting to be able to tell when we are close enough to an object to interact with it. Remember to subscribe and click the notification bell to stay up to date with every tutorial I upload, and I will see you next time.